Josh Puala, you see this mistake right here? Where's my mistake? Got the H. And so I took it and I just put it on its side, just like rolling a quarter down on the floor or something like that. And then I tried to do this by hand. And I had this crazy function that's right here, and I tried to show you all the different disks. And I was showing that this was delta x. And then, just because I think it's important that we see a limit every once in a while, I put it in limit form. As delta x is getting to 0, what does that mean? I have skinnier disks, right? And I'm adding up all the volumes. And here's my pi, right, because I can bring it out because it's a constant. Here's my radius squared. Here's my height of my cylinder. And another way for me to write that is just like what I have on the board. See how this fits in to what you saw, to what we talked about. Now, if I have a horizontal axis of revolution, it looks like this. If I have a vertical axis of revolution, it looks like this. And then I give you an example. If I am going to compute the volume of this, what would be the integral I would set up? You have pi. Hello? I'd have pi, okay? That's safe. What else would I have? I started really hard because it was trig. Scared me. No one knows anything else they can contribute. Oh, why can I put it in there without the square root? Okay, so when I square this, I'll eliminate the square root. Okay. Okay. So far, so good. What else? What? dx. Awesome. Perfect so far. What else? You guys had Mr. Karsh last year, right? What does this do? Moves the function which way? To the right, how far? 3 pi over 4, right? Do you agree with that? Somebody in their calculator, what is 3 times pi divided by 4? Two point what? 356. So right here, would you say that's about 2.356? Correct? So this shifted from here 3 pi over 4, correct? So where was this? Where is cosine 0 normally? Pi over 2, right? So that means this has to be pi over 2 plus 3 pi over 4. Would you agree with that? Because it shifts to the right that far? Roman, would you agree with that? And this is 2 pi over 2, so this has to be 5 pi over 4. That's what I'm guessing. So on your calculator, take 5 times pi and divide it by 4. Do I get a number that's almost 4? 3.927. Take a look where the dot is. Does that look like 3.927? Hi, how was that physics test?
2 hours.
2 hours. Awesome. So what does this have to be? Ah, 3 pi over 4 minus pi over 2, right? And that's the same as 3 pi over 4 minus 2 pi over 4. So this has got to be pi over 4, or about 0.7 something, right? Does that look like that's 0.7 something? Yeah. So what am I going to do next? Can I finish my integral? You're saying yeah, so do it for me.
Just integrate from pi over 4 to 5 pi over 4.
Perfect. Alrighty. What's the antiderivative for this? Well, I look in parentheses. I see if its derivative exists in the integral, correct? What's the derivative of this thing in parentheses? 1. Does it exist in the integral? 1's everywhere, right? Okay, so I could simply take the antiderivative of cosine, which is sine. Awesome. So I have pi times the sine. You guys are scaring me today. I'm feeling like I'm speaking Swahili all of a sudden. From pi over 4 to 5 pi over 4. So this is going to be pi times the sine. Well, what's 5 pi over 4 minus 3 pi over 4? What? Pi over 2? Okay. Minus pi times the sine of pi over 4 minus 3 pi over 4. What's that? Negative pi over 2. Okay? I haven't lost anybody yet, have I? Okay, what's the sine of pi over 2? Do you know? 1. So this is pi times 1 minus pi. Oh, this is the same person. No. It is. Times, well, what's the sine of a negative pi over 2? Negative 1. So what's my answer here? 2 pi. That wasn't terrible. Next page. So I have this equation. So my discs are revolving around this way, right? So my thickness right here is dy. So I got this pi out here. What's A and B, Megan Carlson? I'll give you a hint. It's starting down here, right? Let's go all the way to here. Did you get the sound effects? Do you have a younger sibling? Don't you? You have an older sibling? Okay. Did your older sibling ever grab you by the legs and spin you around? No. Did anybody ever have that happen to them? Awesome. Okay. Did they ever let you go and see how far you could skip?
Not that I remember.
Okay.
I might have gotten hit on the head though.
I was great. It was easier to toss Bill than Bruce. He was more aerodynamic. You should hear him scream when they land. Okay. So anyway, back over here. I don't know how you got it. Megan, what am I integrating from what to what? 0 to 3. Perfect. Okay. So now, here's my radius, right? What's my radius? Is it x squared? Why can't I put x squared in there, Kastrima? It says x squared right here. You have no idea. You're still thinking physics. Caitlin, why can't I put x squared in there? Yep, and it's all got to be in terms of y. And I got the dy here. I wrote that down for a reason. So I need this in terms of y. Is this in terms of y? No, it's in terms of x, isn't it, Brogan? Could I write this? Can I get it in terms of what? What is it? Hello? I'm giving notes. Okay, sure will. All right, bye. Okay, so which one is this? Is it the plus or is it the minus? Plus, because it's on that side, so I can do this. Am I liking that, Jonah?
Yep.
Why?
Because that square root and squared cancel each other out.
So I get y. Isn't that y?
Yep.
Okay, Allie Murphy. You gotta make sure you go to the office sometime. All right? Can you take the antiderivative of y for me? Right, so I have, do you see where I get pi over 2? Y squared, evaluated from 0 to 3. And so I get pi over 2 times, I think that's 9, isn't it? Minus what? 0. And I get 9 pi over 2. All right.